So now, we proceed to the examples. For the first example, these are three resistors with different resistance. I gave the first one 2 ohm, the second 3 ohm, and the third 6 ohm. Now, when we need to calculate the effective resistance, we must identify whether the circuit here is a series or a parallel circuit. We can see from here it's connected end to end. So we can see that this is a series. And using the series formula, R total equals to R1 plus R2 plus R3. So when we need to calculate the R total, we take the R1, which is the 2 ohm, plus the R2, 3 ohm, plus the R3, 6 ohm. Therefore, we can know that the total resistance between these 2 points is 11 ohm. Next, the second example. Here, we are given 2 resistors with each resistance as 2 ohm and 4 ohm. Again, we need to calculate the total resistance between these 2 points. First thing, identify whether it is a series or a parallel. In this case, they are connected side by side. Therefore, we can conclude that this is a parallel circuit. Applying the parallel formula, 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. So, 1 over R total equals to 1 over R1, which is 2 ohm, plus 1 over R2, which is 4 ohm. And you get 1 over R total equals to 3 over 4. Now pay attention here. Your calculation does not end here, as you need to calculate the R total, not the 1 over R total. Therefore, you need to invert the fraction here so that you get R total equals to 4 over 3 ohm. Be careful not to get tricked by this. Next, the third example. There are 4 resistors here. This one with 7 ohm, 1 ohm, 3 ohm, and 4 ohm. Now, in this case, you can see that you need to identify, before you do anything, you need to identify whether this is a series or parallel. Now, you can see there is a series, parallel, and a series here. But you must see that this whole thing is series in a whole. So, but you need to change this parallel section here to a combined resistor so that it becomes a series. So how do you do it? First thing, the parallel here, you can't just take the parallel formula here because there is a series connection over here. Therefore, the first thing you need to do is, I assume this whole section as R1 so that you can get a combined resistance over this section. So R1 applying the series formula equals to 1 plus 3 ohm, you get 4 ohm. So this section, you can change it to a 4 ohm resistor. The next step, you need to change this whole parallel section here into one combined resistor. So again, I take this as R2. So when you need to calculate the combined resistor here, combined resistance here, you need to take R1. Since it is a parallel circuit, so you use the parallel formula. R1, which is combined 4 plus another 4 here. This is R2. You will get 2 over 4. And don't forget, this is still in 1 over R. So invert the fraction, you get R2 equals to 2 ohm. And lastly, you need to calculate the total resistance between the point here and here. So you can see that we already changed this whole thing into a 2 ohm resistor. So let's plot another circuit diagram. This is the 7 ohm, and the whole thing here, we change it into another single resistor here. So it will be 7 ohm here, and the total is 2 ohm. Now it's much more easier, right? So you apply the series formula, which is R total equals to R1 plus R2. You get a total combined resistance of 9 ohm. So that's all for effective resistance. Thank you for watching, and hope you like our videos and subscribe to our channel.